So starting with the first major stage of respiration, and that is glycolysis. This is basically the first stage, and it occurs in situations where you have oxygen and also in situations where you don't have oxygen. So we say that it occurs in aerobic and anaerobic conditions. So the emphasis here is that even in absence of oxygen, it can still occur. So it can occur in aerobic and anaerobic conditions. Ultimately, the end goal is that you have two pyruvate molecules that you get from glucose. With glycolysis, you end up with two pyruvate molecules. And the entry point or the starting point is glucose. Okay, we can look at the process of glycolysis in three stages. Phosphorylation, which is the addition of the phosphate group, or phosphate groups. Okay, that's one stage. And then the second stage is splitting, having a 6-carbon compound being split into two compounds of 3 carbons, carbon atoms. And then the last being oxidation, which is basically removal of hydrogen, like I've just said. But if you are to go into details, you realize that actually the steps are 10. As you can see from the image, we have step 1 up to step 10. Okay, so those are the steps that we'll actually look at in this presentation instead of looking at only 3. So, depending on whether you have oxygen or not, the end products will differ. Or what happens to the end product will actually differ. So when you have no oxygen, that is in anaerobic conditions, you will have the pyruvate being converted to lactic acid, what we call lactic acid fermentation. And this is what happens if you do extensive exercise in a very short period. Your body utilizes the glucose to make sure that you have the energy, but of course you run out of oxygen, and then what happens is that the glucose is being broken down when you don't have oxygen, and at the end you get lactic acid, okay, under what we call lactic acid fermentation. In presence of oxygen, then the process will be smooth, where you have pyruvate being converted into acetyl-CoA, and this is what enters the citric cycle, what we call Krebs cycle. So end products of glycolysis, that glycolysis is actually very important because it gives you energy very fast in a short period of time. You have that energy that you need. You have 4 ATP molecules that are produced, but you use 2 of them in that process. So therefore you have the net number of ATP molecules is actually 2. And then you have a coenzyme that is NADH. Okay, nicotinamide adenine dinucleotide is what we are talking about here as the cofactor. Okay, it will be reduced to NADH. Okay, so this is actually very important in the other process, that is the oxidative phosphorylation, and you will see how that enters that cycle, that oxidative phosphorylation. Okay, so those are the end products. That's what we get. Okay, net, you get 2 ATP molecules, you get 2 pyruvate molecules, and then you get 2 reduced NADH. Okay, so we looked at lactic acid fermentation, but a similar process happens in the yeast, and we call it alcoholic fermentation. Okay, this is where you have you don't have oxygen, and then you end up with an alcohol. Okay, and alcohol. So pyruvate is converted into the aldehyde, and then the aldehyde finally into water.